Hey guys, so we're back with video 4 and we're going to work through an example on a sheet of paper, okay? So this is the example we're going to work through. It's the next one in your slides. So it says SO3 decomposes at high temperatures in a sealed vessel. Initially, the vessel is charged at 1000 Kelvin with SO3 gas at a partial pressure of 0.5 atmospheres. So that's the initial pressure of your singular reactant, which is SO3. At equilibrium, the pressure of this singular reactant is 0.2 atmospheres. Calculate the value of Kp for the reaction at 1000 Kelvin. So this is isothermal. We haven't changed temperatures. They're giving us pressures, and they've asked us for Kp. All right, so there's no weird relationship that you have to do between Kc and Kp. And my promise to you is this: I will never ask you to relate Kc to Kp in a question like this. If I ask you to relate Kc to Kp, it will be in its own separate question like what we did in the previous lecture. Okay? All right, so now we're going to go to the piece of paper and we're going to work this out. Okay, first thing you need to do is you need to have your balanced chemical equation written down. All right? So that's the first thing we're going to do. So we have 2 SO3 gas. Notice I am spacing this out. I'm spacing it out because I want to have room to write. Goes to make 2 SO2 gas plus oxygen gas. Big space there. Okay? All right. Now, ICE. You can draw lines, but it's not necessary to draw lines. All right. Initial concentration of SO3 is 0.5. Did they tell you an initial concentration for your products? No, they didn't, which means we assume they are 0. What is the equilibrium concentration of your reactant? They gave you that. They told you it was 0.2. All right. So, step 1, we tabulated everything that we know. Step 2, we're going to figure out the change of the guy we know initial and equilibrium for. So if we started with 0.5 and we ended with 0.2, then we lost 0.3. Right? If we started with 0.5 and we ended with 0.2, we lost 0.3. Now, what do you notice about the relationship between SO3 and SO2? SO3 to SO2 is a 2-to-2 relationship. Okay? Which means that if the coefficients are the same, then the change should be exactly the same, except for this is a product, so it's going to be plus 0.3. All right? Now, but take a look at oxygen, though. Oxygen does not have the same reactant, or the same coefficient, I'm sorry. So we're going to start with 0.3, and this relates. This is the change of SO3. We're going to divide by the coefficient of what we have. So for every 2 moles of SO3, we have 1 mole of oxygen. Okay? So 0.3 divided by 2 is 0.15. All right, so this one's going to be 0.15. Then your equilibriums are pretty straightforward to determine next. 0 plus 0.3 is 0.3. 0 plus 0.15 is 0.15. Okay? Now we're going to write our Kp expression. So Kp is equal to the partial pressure of sulfur dioxide squared times the partial pressure of oxygen divided by the partial pressure of SO3 squared. And then we just plug in our values. So SO2 is going to be 0.3, and that's squared. Oxygen is going to be 0.15, and then SO3 is 0.2, and that is squared. Okay, we put this in our calculator, so 0.3 squared times 0.15 divided by 0.2 squared I got 0.338. And if we go to the slide sort of steps you through this, everything I just did. And yes, we got it right. KP is 0.338. All right. Okay, so that's the end of this video. I'll see you back in screencast for the next video.